All right, we're going to start factoring. Our goal is to get to where we can solve quadratic equations, and to be able to do that, we have to be able to factor. Now, factor, when we're talking about polynomials, is the inverse operation of multiplying. Factoring undoes multiplying. Okay, they're inverse operations. So we're going to use the distributive property to factor polynomials, and then we're also going to use something called the zero product property to solve some equations. All right, so write these examples down as we go because none of this is in your book. It says to use the distributive property to factor each polynomial. So the first one they give us is 27y squared plus 18y. Now you remember how the distributive property works, right? Like if you had A times the quantity B plus C, you'd multiply the A times the B, then you'd multiply the A times the C. So that's using the distributive property to multiply. So to use the distributive property to factor, we go in the opposite direction. So you're looking for common factors. You're looking for things, you're looking for factors. Factors are things that are multiplied together. You're looking for factors that are in both of those terms. So you look at the coefficients first, the 27 and the 18. So factors of 27 are, like 1 times 27, 3 times 9, okay? Factors of 18, like 1 times 18, 2 times 9. I didn't list them all. I'm just giving you some examples. So the easiest way to go about figuring out the greatest, the biggest common factor, they both have it as a factor, is to just ask yourself, what's the biggest number that divides into 27 and 18? Well, what is the biggest number that divides into 27 and into 18? So we're going to factor out a 9. And then you go to your variables. And it's the same idea, okay? What's the biggest y? In other words, y to what exponent divides into y squared and into y? Y to the first. Now here's the trick. Here's the thing. This is called the greatest common factor. But with variables, you always use the smallest exponent. If you see a y in both terms, you always use whichever y has the smallest exponent. I know it's called greatest common factor. We emphasize the greatest sometimes. Common is what we really need to be thinking. The second term doesn't have a y squared, does it? But the first one has a y. Y squared is y times y. Okay, so you always end up using the smallest exponent. Always. All right, so 9y is our greatest common factor. Now, to see what's left in the parentheses. So remember what we're doing. We've decided, we've figured out what the A is. Now we got to figure out what's left inside the parentheses. What's the B? What's the C? And you do it by division because, remember, factoring is the inverse operation of multiplying. So you do it by division. So what's 27 divided by 9? 3. What's y squared divided by y? Y. And then since there's a plus sign between the terms, plus, what's 18 divided by 9? 2. What's y divided by y? Not 0. It's 1. It's y to the 0, or it's 1. Do I need to put y to the 0? No, because what does y to the 0 equal? 1. Do I need to put times 1? No, because that doesn't do anything. And we have factored this using the distributive property. Okay? Now, from time to time, you might catch yourself, I'm not getting the greatest common factor. Like, for instance, what if we'd taken out a 3 y. Then we would have said 27 divided by 3 is 9. Y squared divided by y is y. 18 divided by 3 is 6. Y divided by y is 1. And we get that. That's not incorrect. I mean, that really does equal 27y squared plus 18y. But it's not the complete factorization. If you notice, don't those two terms still have a common factor? They still have a common factor of 3, don't they? So then we would say, okay, so that's 3y. Factor out another 3. 9 divided by 3 is 3. Y, there's nothing to divide the y by, so y. 6 divided by 3 is 2. And you'd say, oh, 3y3. We don't call it 3y3. 3 times 3 is 9y. So do we end up at the same place? Well, yeah. Wouldn't we rather do it the first way, though? Yeah, that's why you look for the greatest common factor. Okay? Any questions? All right. Let's, we'll come back to 1A. Let's go with 1B here. So keep writing these down. We have 7u squared t squared plus 21 ut squared minus ut. Now that last term that you don't see a coefficient for, what's the coefficient? 1. Actually, it's a negative 1. We'll be careful with the signs. Okay. So you look at the coefficients first. Well, what's the biggest number then that divides into 7, 21, and 1? 1. Any need to factor out a 1? No, that didn't do you any good, does it? Dividing out a 1 doesn't change anything. So there is no numerical GCF. So let's look at the u's. We've got a u squared, and then a u, and then a u. What's the biggest? U. All right, because you remember, we say biggest, but we mean smallest exponent. So we factor out a u. What about t squared, t? Factor out a t. Now, I did not write a coefficient in front of ut that I factored out, but what is it? 1. So 7 divided by 1, 7. U squared divided by u, t squared divided by t. Okay. Then it's a plus sign. 21 divided by 1. U divided by u. 1. Do I need to write a factor of 1? No. T squared divided by t. Minus sign. Well, both coefficients are 1. 1 divided by 1 is 1. U divided by u. 1. T divided by t. Now, previously we'd always said, don't bother writing down a factor of 1. It doesn't do anything. That mean I just end right there with a minus sign at the end? This time I really do need the factor of 1, don't I? When 1's the only factor, you do have to put it. And look, here's the thing. As long as you're willing to work, you'll never miss one of these. Because can't you always just take your answer, multiply it back out, and make sure you get the original problem? Okay? In fact, a lot of books always say something like, you know, factor and multiply to check your work or something like that. And I'm not going to make you do that, at least not on paper. But if this was a quiz, I would mentally make sure, okay, UT times 7 UT, yeah, that's right. You know, you've got to be able to multiply it back out and get the original problem. You've got to. Okay? Do 1A all by yourself. What's the greatest common factor? 3. 3W, 3V, 3. All right, so what's 15 divided by 3? And then W divided by, there's nothing to divide it by. Technically, you're dividing it by an imaginary factor of 1 there, okay? But there's nothing to divide the W by. Minus sign. 3 divided by 3, 1. V, nothing to divide it by, so I do need to write down the 1, don't I? Is that what you guys got?
So why don't you write down?
Because I'm an idiot. I did. You know, I messed up 3 times last week. Oh. Yeah, back in my heyday when I was young and could think, I bet a class, like on the first day of school, that I wouldn't make any mistakes all year, and I didn't. But that's when I was young and on top of things. No. See, flattery is one thing. Lying? All right. We good? Okay. Try those on for size. Take a few minutes to do each of those. Check these and see if you got the correct answer. Any questions? No trouble? Good. All right, the zero product property. We're going to use the zero product property to solve equations. The idea is this. Whenever you multiply 2 numbers together and the product, the result, is 0, one or both of those numbers have to be 0. There's no other way around it, is there? Okay? Anytime you multiply 2 or 3 or 15 numbers together and the product is 0, at least one of those numbers must be 0. Maybe they are all 0, but we know for a fact that at least one of them is. And that's the way we're going to solve equations. If we have 2 factors multiplied together and the result is 0, we know that at least one of the factors equals 0. So we set each factor equal to 0. Kind of like this. So write this example down. They have factored this for us. We have a factor of 2d plus 6 and a factor of 3d minus 15. Now, this particular factorization is not complete. Each of those, in each parentheses, I could factor out a greatest common factor, but we have 2 factors multiplied together, and they equal 0. Now, it's really important that the 2 factors have a product of 0. If their product is 28, well, that doesn't mean that one of those factors equals 0, does it? Okay, so the product must equal 0. And since it does, the zero product property tells us that 2d plus 6 equals 0, or 3d minus 15 equals 0. Now, in math, the word or kind of means and or. It doesn't mean exclusively it's either this one or it's this one. Now, d can't equal 2 different things at the same time. But d can equal 2 different things to make that equation equal 0. Okay? I mean, not at the same time. It can't be 12 and 14 at the same time. But if 12 makes it equal 0, that's a solution. If 14 makes the equation equal 0, then that's a solution. Okay? So we will expect to get more than one solution. Okay? Now, here we go. If 2d plus 6 equals 0, well, we know how to solve that. You subtract 6 from both sides, and then you divide both sides by 2. Or 3d minus 15 equals 0. And we know how to solve that. 3d equals 15, d equals 5. So that's our solution. D equals negative 3 or D equals 5. And these also, you should always be able to check to make sure you get them right. Okay? If I took negative 3 and substituted it in right there, 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. 0 times. Do I even care what the other parentheses would work out to equal? No, because 0 times it equals 0. And then the same thing with the 5. Put 5 right there. 3 times 5 is 15. 15 minus 15 is 0. I don't care what number's in the first parentheses. Times 0 equals 0. Okay? Any questions? All right. Let's do 4b first. Let's do 4b. Now this one is not factored, so we need to factor. What's the greatest common factor of 8 and 40? 8. Of b squared and b? Parentheses. 8b squared divided by 8b? b minus sign. 40b divided by 8b? 0. Now we have two factors once again, and the product of these two factors is 0. The zero product property says that 8b equals 0 or b minus 5 equals 0. That's right. You divide by 8, you get b equals 0, or what else? B equals 5 when you add 5 to both sides. Yes. Yep. However many factors your equation has, that's how many solutions you will get. So you'll have typically 2 simple linear equations to solve. I mean, they might give us 15 factors, in which case you'd have 15 simple linear equations to solve. All right, do 4a on your own. It's already factored for you. Get what I got? All right. On this last thing, 4c, we got to do a little work here before we can, well, definitely before we can solve, even before we can factor, because we don't have 2 or 3 or any number of factors equal to 0, do we? So we've got to get the term on one side of the equals for one thing, so that there's a 0 on the other. So let's add 10x to both. Leave the x squared alone. Add 10x to both sides. You end up with that, don't you? Are we now in position to factor? Yeah. So, listen closely. Whenever your equation's not prepackaged for you, already factored, or all the terms in order for you, here's what you want to do. you want to get all the terms on one side and 0 on the other side of your equation. And you want your first term to be positive. That's not a hard and fast rule that you have to obey, but it sure makes the work easy. So all the terms on one side of the equals, 0 on the other, first term positive. Oh, and arrange the terms in order from biggest exponent to smallest if you can. Okay, if there's a bunch of different variables in there, you may not be able to. But arrange them in order from biggest to smallest. All right, so that's what I've done. What's the greatest common factor of x squared and 10x? Just x, isn't it? So, x, what do I get inside the parentheses? X plus 10 equals 0. Does the 0 product property apply here? Yeah. So x equals 0 or x plus 10 equals 0. So x equals 0 or x equals negative 10. All right. Any questions? All right. Do these. Solve each equation. Questions? You have something to work for you? Number 11. Number 11. All right, we've got 20 t squared and 15t equals 0. So we've got the equation the way we want it. We've got factors there. So for 20 and 15, greatest common factor, 5, t squared and t. So 20 t squared divided by 5p is 4p minus sign. 15p divided by 5p, 3 equals 0. So now apply your 0 product property. Either the first factor equals 0 or the second one does. On the first equation then, divide by 5. The second equation, add 3 to both sides and divide by 4. And we get 0 or 3. Any others? Always factor. Well, I mean, if they're not factors, factors. You see, this is factors because it's 3k times. Factors are multiplied, so it's times. That's a factor because it's k plus 10 times the 3k. So if it's not already factored, factor. Does that make sense? All right. Any other questions on these four? Okay. Now, one other thing we can do to help us factor is we can factor by grouping. All right. So it says a polynomial can be factored by grouping only if all of the following conditions exist. There are 4 or more terms. Terms have common factors that can be grouped together. And there are 2 common factors that are identical or additive inverses of one another. Additive inverse, what's that? Yeah, opposites, what I've always called them. You add them together, you get 0. All right, so here's what we're talking about. So write this down. 4QR plus 8R plus 3Q plus 6. And they want us to factor this. Now, hopefully, they've given these terms to us in an order where it's good to factor them. So what we do is we look at the first two terms as a group and then the second two terms as a group. Those first two terms, is there a common factor? What is it? 4 and R, 4R. So equals 4R. Okay, what's 4QR divided by 4R? Q. What's 8R divided by 4R? 2. 8 divided by 4 is 2. Okay? Now, in the second group, what's the greatest common factor? 3. Now look, I didn't put a sign on the 4R because if you have a string of terms written down, the first term is positive unless there's a negative sign in front of it, right? But everything else always has to have a sign in front of it, either a plus or a minus. So I'm factoring out a 3, and I have to indicate that it's a positive 3. And what am I left with inside the parentheses? Q plus 2. And now, here's where some folks struggle sometimes. See how there's a factor of Q plus 2 in both of those terms. Believe it or not, we can consider that to be a term. We can consider that to be a term. And Q plus 2 is a factor in each of those terms. So Q plus 2 is now our greatest common factor. So we do what we've been doing. We put it in front, parentheses. Now, that first term, the 4R times quantity Q plus 2. If I divide out the Q plus 2, what am I left with? Just 4R. And then for the second term, the second behind the plus sign, the 3 times the quantity Q plus 2. Again, if I divide out the Q plus 2 so that it's gone, what am I left with? And it's a positive 3.
Why can't you do that? Or why can't you just get R?
I did get 4R plus 3.
But I mean, like, without the.
Well, because I divided it out of each term. I didn't divide it, I didn't divide both sides of an equation by it to make it go away. Okay? Make sense? A little more challenging? Yeah, I'd say. All right, let's take a look at this one. The first two terms, the Rn plus 5n. What can we factor out? N. And what are we left with? Right? If I have Rn and I divide it by n, I get R. 5n divided by n, I get 5. So I get n times the quantity, R plus 5. And then look at those last two terms. It's a negative R and a negative 5. And you're probably going to want to say, because I would, there's nothing to divide out. But look how this first one worked. We need, for each of our terms that we get as a result, to have a common factor. In this case, we need it to be R plus 5 for the one we're working now, don't we? Is there any way to make that into an R plus 5? Divide by negative 1. So it's hard to believe, but our greatest common factor is negative 1. At least the greatest common factor that's useful. So negative 1, parentheses, negative R divided by negative 1 is positive R. Negative 5 divided by negative 1 is positive 5. So, what's our greatest common factor now? So we factor out the R plus 5. And what are we left with? N from the first term minus 1 from the second term. Any questions? Do that next one. Do 2b. Did you get what I got? Did I get it right? Do what now? Uh, no, the p's 3p times 5 gives you 15p. Okay. Yep. Yep. Okay, we good? Let's take a look at this one. All right, so from the first group, what can we factor out? From the first pair. 2m. All right, so in our parentheses, what's the first term in our parentheses? K. What's the second term in our parentheses? What kind of 6? Negative 6. Okay. Well, I guess I should wait, shouldn't I? So from the second pair, the 42, the 42, and the negative 7k, what divides into both of those? 7. Now, I'm not going to put a sign yet, because I'm not sure if I should be factoring out a negative 7 or a positive 7. I need to see what this thing looks like. I'll do a positive 7 first. If I do a positive 7, what's 42 divided by positive 7? 6. And negative 7k divided by positive 7? Negative k. Is that what I want? Is 6 minus k the same thing as k minus 6? No. So let's make that a negative 7 I'm dividing out. So now, what's 42 divided by negative 7? Negative 6. And then what's negative 7k divided by negative 7? Positive k. Now, is k minus 6 and negative 6 plus k the same thing? Those two are the same thing. Okay? So, you don't really have to take a step to rewrite this, but I want to because I want you to see it. Negative 6 plus k can be written as k minus 6. And now I see the next greatest common factor, don't you? It's k minus 6 times 2m minus 7. And so, we have a worksheet.